Hello, welcome back. If you've watched the previous video, then you should probably remember that we ended that with me breadboarding up a minimal schematic to run the XR2206 Function Generator chip, and this is the actual circuit. And then this is that converted onto a breadboard. So we have the chip itself, we have the power filtering over here. This is the amplitude pot, which feeds into pin 3. This is the frequency pot, which feeds into pin 7. And then this, if you can see it, is the timing capacitor that sits between pins 5 and 6. So that's really the minimum we need to run an XR2206. And last time, I'm sure you remember, it didn't work. And it absolutely doesn't work. So if we bring in the oscilloscope, connect it up to the ground for this circuit and to the what should be the triangle wave output, and then bring some power in to the circuit, which is the 12 volts. Make sure that's actually switched on. It is, and we get absolutely nothing. It's essentially dead, and this is what we decided last time, was that it was the chip that was had failed. I'll just disconnect that. Now the exciting news, which you might be able to tell from the title card for the video, is that we have a replacement. And just to check, there you go, that's the oscilloscope working absolutely fine with its own internal signal generator, well, square wave generator. So nothing out of this circuit on the oscilloscope. So we have here a replacement chip. So this, if that's focused, is the wrong way up. Yeah, so this is the new chip. This has the XR logo on it. I don't know if that means that's genuine. I doubt it somehow. It may just be a better counterfeit, but we'll see when we actually try and work it. So what I will do is switch out this chip, now the power's off. Pop in the new chip, making sure I get it in roughly the right place. There we go. So just check, we're getting ground going to pin 1, we're getting the VCC going to pin 4. So that's exactly where we want it to be. And everything else is set up the same. So now if I put power onto this, lo and behold, we actually get a triangle wave, and I should be able to change the frequency here, and I should be able to tune the amplitude as long as I don't dislodge that pot completely. So that's brilliant. So that is at the very least working. We should be able to quickly check and see if we get a square wave. We are getting a square wave. It looks a little bit dodgy, but we'll come back to that, I think, later on. So back to the triangle wave. So that's working fine. That's good. I'm happy with that. We'll pop it in the board in a minute and see what sort of frequency range we can get with this, or what we can actually measure with the DSO138. But there are a couple of things I want to try before I do that. So the first thing, so in this minimal schematic, we have no connection on pins 13 and 14. So that's fine. If those pins are not connected to each other, then you get the triangle wave, which is what we have at the moment. If you do connect them together, then you should get a sine wave. If you put a variable resistor in between them, then you should be able to tune that sine wave to get its total harmonic distortion about right. And this, again, looks just about perfect. So the amplitude is a little bit less for the sine wave than it was for the corresponding triangle wave, but generally it looks very nice. If we take the frequency down a bit, you can see that looks like a very nice sine wave indeed. It doesn't look like there's much distortion there at all, and we can hoik that frequency right up. Excellent. So what are we at there? So we're about 2.5 kilohertz there, and that's brilliant. So I think we can say the chip itself is working now, and it definitely was the old chip that was the problem. Okay, so if we quickly go back to that schematic of this circuit, the other two pins that are not connected, well, there's two down here which we're not interested in, but the other two here should allow us to change the symmetry of the triangle wave, to convert it from a triangle to be a sawtooth wave. And this is something that I want to have, want to be able to do. The debate is whether this is actually implemented in this chip. So the original chip definitely would do this, but some of the Chinese counterfeit chips don't. So what I'll do now is just quickly change that circuit so that we can test it on this chip. Okay, so I have quickly changed the circuit again. So I have got rid of the 330 ohm resistor that was bridging pins 13 and 14. And what I have done is I have connected in this potentiometer, which you can just about see here. So this is now, each end of the potentiometer is connected to pin 15 and 16, and then the wiper is connected to ground. So if we look at the circuits that Roger set up, just up in the top right there, you can see the symmetry control, and we have pins 1 and 3 connected to 15 and 16 on the chip, and pin 2 of the wiper connected to ground. And this matches exactly what's in the data sheet for the chip. Okay, I don't have a 25k ohm resistor. I have a 50k ohm resistor, and I put that in, and we'll see what it does. So if I now tweak this potentiometer here, we should see the shape of the triangle wave changing to a sawtooth. Now, there is absolutely nothing happening. That happens if I take it right to the end, but as far as I can see from this now, I'm seeing no difference whatsoever. Okay, let me just quickly change the time base, and let's have a quick look again. So if I go fully to one end, we get a slight kink at the top and the bottom of the trace, and if I go right to the other end, then we get the top flattened off completely. So it's not doing what I'd expect it to do, which is a little bit disappointing. So it's probably not worth trying to worry too much about the symmetry control, but there are a couple of other changes that we'd want to do to this, and I'll just quickly, I think, take this out of the breadboard, pop it onto the original board, and see how we get on with that circuit there. Okay, so we have now the chip in the original board running, generating a triangle wave. We can tweak that triangle wave, change its frequency with the fine and the coarse potentiometers. We can change the amplitude. That's good. We should be able to change this jumper and change it into a sine wave. All looking great, exactly as with the board is spec'd to do. So that's fine. That's good. It's working. We now have a new chip in there that's good, so that's no problem at all. And I will be able to use this. I will very, very quickly just check on the square wave output from this. Pop the back in, and yeah, there we have a decent square wave coming out of the generator. Let me have a little bit of a tweak of this, and there we go. So one thing we can't do is change the amplitude of the square wave. This should be 0 to 5 volts. It also, as it stands, it doesn't limit the current that you can potentially draw from that. So there's a risk of this damaging stuff later. So any digital electronics that you connect to it. So what can we say? So if you remember when I checked the internal function generator on the oscilloscope, we see exactly the same rounding at the top and bottom edges of the square wave, which suggests that the calibration on the oscilloscope is not right. Given that we didn't have an external function generator, we couldn't tell whether that was the oscilloscope or the function generator within the oscilloscope that was the problem. Now there is a trim pot on here which you can no longer see because I've put the acrylic case on. It looks like I'm going to have to take that off and try and calibrate it. I have tried this in the past and it hasn't been hugely successful. And I suspect very much that the trim capacitor on the board is not good. So I might have to have a think about getting a new one of those and seeing if we can improve that calibration a bit. But generally, I'm pretty happy with that. It kind of does most of what I need, but not everything. I really want to be able to get sawtooth waves out of this, and that's not going to happen with this chip. There are a few other things. If I quickly go back to the schematic, actually let's have a look at it in KiCad. So this is the control here that controls the symmetry, and we're not particularly interested in implementing that. I don't think I'm going to bother with that at all. Roger from Kinker Labs did implement this by jerry-wiring a potentiometer across that connector, so you could tune the sine wave to get the best possible shape. And that's great. I think that would be worth doing. This jumper connection up here on the board, basically if you want a sine wave, then you have those two pins connected, 13 and 14, and there is I believe a 330 ohm resistor in the way of that. It would be nice to be able to tweak that. It would be nice if that was a switch rather than a jumper, but we can do something about that, I think. So the other things that could do with being tweaked on here, apart from the symmetry up here and the THD connection. The value of this fine frequency adjustment pot in this board is 50k. If we drop that to 10k, that should give us a bit finer control over the frequency than the 50k. I will probably put in a diode here to actually just protect against reverse polarity connection. I know a lot of people out there who deal with a lot of electronics will be thinking, why would you worry about that? Because everything's always center positive. A significant subset of guitar effects pedals are center negative for reasons that I just don't understand. Not all of them, just some of them. So quite often I have power supplies set up that are center negative. I just want to guard against me doing something stupid with that. But I think that's about it. And that's about as much as we can get out of this board. Like I think I said, it would be nice if this could generate sawtooth. If it can't, then it can't. And we'll have to look for something else. Okay, so I will have a look at this circuit at some point. I am not going to do this in the next video, but I think it might well be worth actually designing a circuit board that we can put this chip onto that does a slightly better job than this one. I might even implement the possibility of the symmetry control as well, just in case there is a source somewhere of genuine 2206 chips, but we'll have to see about that. So next time, I think, because I was ordering the new chips from AliExpress, I took the opportunity to order this, which is a kit, another kit. This actually is a kit this time. I thought the original one was a kit, but it came fully built. But this one uses a different chip. So this uses the ICL8038 signal generator chip that can natively generate sawtooth waves. So it has a separate output for sawtooth waves compared with the just the square wave and the sine triangle output. This board does not support the sawtooth wave output, so we'll see how that works out once this is built. But I think that'll be the next video, is building this up and testing it out and seeing what its output looks like on the oscilloscope. And hopefully this will be slightly better than what we've got here. I'm not entirely hopeful that this is going to solve exactly what I need, so I think we might have to look at other possibilities. Someone in the comments on the first video, thank you very much, suggested direct digital synthesis, and that's something that I've had a look at. And I think that's this is where you just get a microcontroller, you use its digital to analog converter to generate any arbitrary waveform that you want. And that, I think, is probably a good solution. And the cost of microcontrollers these days being in the sort of £1 to £3 range for the best ones, I think might well sway me to do that. What I'll have to be sure is that I can generate the waves that I need at the frequencies that I need, which could be anything up to 60 kilohertz is going to be what's crucial for me. Whether we can do that reliably and get a smooth wave out of a microcontroller. I don't think it'll be too hard. I think it's possible, but there are other possibilities as well, so I'll be looking at those as well. So thank you again for watching. If you've managed to get this far, I know most people don't, but thanks for getting to the end. If you're interested in this, please give us a like. That really helps. subscribing as well really helps. So yeah, thanks very much, and I'll see you in the next video.